There we go. Okay, so let's get back into it. We started out this week talking about how to sign up for OSC. We learned about some commands for moving around in a Linux environment, seeing where we are, seeing what files are in the space where we are. And we learned how to create files or remove files and pipe commands so we can do more than one command at once. We don't have to keep making intermediate files. So think about all of those things as we're moving forward with this next section of our lecture. So in the very last part of our last lecture, we downloaded this chromosome 22 FASTA file. It has a extension of FA for FASTA. So let's log on to OSC and get back to where we did that. So right now I'm in my user space. I need to move into my project space. So I use CD, I do /fs/ESS/PAS1669. So that gets us to our shared project space. These are all old students. I haven't cleaned it up yet, so all of their folders are still here. You're not going to be able to see these. Only I can see them, but they're here. Now, if you remember the last lecture, I created this OSU 0972. 0972. This is where I'm working. We made the CLI folder. And we downloaded this chromosome 22 FASTA file. How big is this? Chromosome 22.fasta. It is 50 megabytes. Let's gzip it because our other example didn't work too well here. Okay. Now, how big is it? It went from 50 megs to 12 megs because it is gzipped. We're going to unzip it. Yep. 2. Okay. And now it's back to just being a flat file. It's sort of like a text file, but it has a different extension. In a Linux environment, doesn't really care what extensions are. So not like a Windows machine where it makes the little symbols. Okay, so we are going back. We're going to continue. We are going to work on manipulating a file. So one thing we can do on a file is we can check what is the word count of our file. And we're specifying this parameter -L for get the number of lines. If we just do word count on chromosome 22, it will tell us these are, one of them's the word count, the line count, and the number of characters, I believe. But the most useful way to use this word count function is to use the -L version. And this will tell us the number of lines in our file. If we did this on our txt file, there's only 2. So if you want to know how many lines are in your file, you'll use this over and over again. Okay. We can use the grep command to search for patterns, the match to patterns. We've used this in the previous lecture. We are going to grep this. We're going to say this is a character, and we're going to put this sign symbol in quotes. Now be sure to put it into quotes, because if you remember the last lecture, we use that to send information to a file. So we're going to grep, we're going to do -C, we're going to do single quote, this assigning character, and then close the quote, and then chromosome 22. This is going to search for what lines have this character present in it. Oh, and it's going to return the index -C. I assume it's going to tell us what line number. I'm not sure. If we do it without the -C, it's going to print that line. So if we look at the head of chromosome 22, you'll see the very first line is the only line that has this greater than symbol, whatever you want to call it. So if we use grep with this -C, it tells us the number of the line. If we take that option out, it will print the actual line for us. I use grep all the time. Grep and awk, which is AWK. You can do all kinds of things using those two together. Okay, so the next thing we're going to do is we're going to use less to look inside our file. Let's see what happens when we use less chromosome 22.fa. And this is going to sort of open the file, sort of like when we looked at that manual for LS. This is a different kind of interface, and we can go up and down in our file. Let's see, I think we're going down. Can we do page down? Eventually, we're going to hit letters. I know they're in here somewhere, but this is using less to open up the file and look inside. Now, if you'll notice, we can't get back to the command line. And I've had students say, I've opened the file with less and I can't get out. The trick is you hit Q. Hit the Q, you go back to the command line. It's not obvious, I know. There's also a more. I never use more. I never use less either. But more lets you look inside of it. I don't know how to use more. Okay. Stop. Quit. Okay. So we've quit out of that. Okay. We're back where we are working. I really never use less or more. If I want to look inside a file, if I want to see the inside and maybe do something, I use VI and the file. The problem is it's going to open your entire file. So we're not going to do that right now. I think we do it later, but let's not do it right now. Let's see. Next, we're going to look at the start codon and the following two codons. So let's see what this does. Highlight it. Oh, I wanted that to be white. Okay. So we're back. We are grabbing. We're using this option called color, and we're looking for this start codon. ATG means start making mRNA. And we're going to ask for what comes after that from our file. Whoa. Okay. And so you'll see it's highlighting these in red. It's just printing them out super fast. We are going to kill this. Oh, it's done. Okay. So you can see now that it's stopped, it's pulled out any line that has ATG in it, and it's highlighting ATG and 6 characters after it. That's what we're doing here with these period dots. It's saying, we don't care what the value is. We just want to have 6 things. And so that's what it's shading. If you don't want to wait for all of that to go, we could do a pipe and do head. It's not going to color it, but we lose that. But these will be the first 10 or so lines that have ATG and 6 more things. Yeah. So you can use a period to be a wild card for a single character. If we did -O, it's going to only print the pattern matches and 1 through per line. Let's try that. Instead of, let's see, we keep color, we just replace it, we take out color and we replace it with O, with a single dash. Yes. Okay, dash O. And so it's printing only things that start with ATG and the 6 characters afterwards. New Control C, that will quit it. We can use the dash O option. We can pipe it into cut and tell cut, select characters 4 through 6. So that's effectively going to cut off the ATG, and we're telling it, give us the first 8. I'm gonna just go up. Cut dash C 4 through 6, and we do head. Yes. Okay, these are going to be the 3 bases that are after our ATG. In this example, we did head dash N of 8, dash N 8. So that's going to be the first 8. N means number, and we tell it the number. We could add in a sort option, and this will take what we pull out. So we're grepping for this, anything that matches this. We are cutting characters 4 through 6. We're going to send it to this sort command, which is sort of like alphabetical sorting. And then we're going to ask for the first 8. So we go back, we add in sort. And the first 8 are all AAAs. So we can do the same thing. Now we're going to add in this unique function, and that's going to collapse them into the unique records. And with the dash C option, it's going to provide a number or a count for how many times did we see this unique listing of AAA. So let's add that in. Unique dash C, we added a pipe. So we're grepping some characters. We're cutting to select the 4th character through the 6th character. We're sorting those. And then we're saying collapse them into the unique listings and provide a count for how often that listing was seen. And then we're printing the first 8. It takes a little bit of time. Okay. So this AAA lowercase was seen 18 times. AAA uppercase was seen nearly 6,000 times. So you'll see the case of our letter matters because it's not going to group lowercase a's with uppercase a's. They are unique things. Okay, so we're down here. We just keep building, don't we? Okay, so the next line we're going to do, we are going to grep for our sequence. We're going to cut to select characters 4 through 6. We're going to sort. We're going to find the unique listings, make a count of them, and then we're going to sort one more time based on the number. That's what dash N means. And then matching this key of 1, 1. So this is going to take all of our counts and sort them so that the most frequent one is first. I'm never going to remember this, so I'm just going to copy this part. Okay. We go up, hit the up key to get our previous command. Delete this part. I'm going to paste. And I'm going to delete this column too. Okay. So we grep for our string. We cut the part that we want. We sort those. Then we say, collapse them into their unique parts and give us a count. And then we say, sort based on that count. I'm going to add in a head right here at the end. So we're going to get the first few. Oh, it's sorted. So the smallest one is first. Okay, let's get the tail then. Tail, the biggest values are going to be at the bottom. The most common 3 base code after our ATG start codon is GGG. It was there 6,037 times. I don't know what we can do with that information, but yes, it's not particularly useful, but it shows us the process of how we can build up a string of operations using pipes in order to find out information. Okay. So that was all about processing a file to get information out of it. The next thing we're going to talk about is symbolic links. So let's say you have a large file that's saved one place in your directory structure, and you don't want to keep referencing that file with the full path. So in the folder that you're working, you want to make, you could just copy it. You could copy it into your folder, but that's going to take up space. So instead of taking up all of the space that would be needed to copy that file into where you're working, you can make a symbolic link. So it's sort of like a shortcut that we have on our Windows machines. It's going to be a file link that links you back to where this file is actually located somewhere else. And so we do that with the ln function, and we use a dash lowercase s. So let's do that. Where are we? We're still in CLI. So we're going to link ln dash lowercase s. We're going to use this path. I will just type it, and I'll use tabs. I'm going to do fs ess pas 1669 to go back and look. RNA-seq reference genome FA. Okay, RNA-seq tab. What's in there? Okay, we want this reference. We tab it. We look and see what's in there. We are trying to link this genome FASTA file. We just have genome. Okay, genome.fa. And then if we look back here, there is a space and a dot after that. Space and a dot. And that's going to tell the environment, put my link right here where I am. So we're linking symbolically this file and plop it down where I am residing. So let's look where we are. Now we have this genome.fa file, and it's light blue. We can use ls-thl. ls-thl. And that is going to tell us this light blue colored file is actually linked to this location, and it gives us the path. It gives us the file name. We just did ls-lh. That gives us the same thing. And we can live in this location and do things to our genome.fa just like it was in the directory with us. So we're going to pull out this symbol from our genome.fa. Make sure the symbol is in quotes, please. It's a big file. So it's going through the whole file and asking where in this file is this symbol. And it's telling us, oh, it's how many times, that's what -c does. How many times is this symbol listed in my file? And it's telling us 194. If we take out the -c, it's going to print out all of those lines. And you'll see it uses that character for the chromosome starts. This is a reference genome file, and it starts out with the information about your chromosome, and then it has your sequence. And so there's going to be one of these lines for every chromosome in our genome file. That's what we're finding out. But if you forgot to put this symbol in quotes, you're going to send information and write over your very important genome.fa file, and that is bad. So it's a good practice to always use quotes around whatever you're grepping. Those are all about symbolic links. Okay. If you're running a program, it outputs two different things. It has the standard output, which is std out, and it has the error, which is std error. So if you're running something, you can tell, as you're running it, you can tell the command line, send my std out to this file. So that's the one. And send my std error to this file. And that's what 2 is. Let me just type. I think I can type C, genome FA. We have 1 going into chars, txt, 2 going into .txt. Is that right? Any okay. And I said this before, in a Linux environment, it doesn't really care about your file, the ends of your file. If it's a text file, it's going to be a text file regardless of what you put after the dot. Okay, so what's in our chars? We print it out. That is the output. That's what happens when we do word count -c of our genome file. What's in our ini? This is the error. Since there is no information generated from running this command, the error file is empty, but this would hold any runtime information, not necessarily errors, just information from running this program. Okay. If you're running commands from the command line and you want to see what is running, you can use top. I don't think I've ever used this command, but there's information about it there if you want to read about it. Okay. Now we're going to get into opening files, typing into files, and looking at our file permissions. So we are going to open up a file called test.sh, and we're going to use a program called VI. VI is a text editor program that you can use command line commands to run it, to open it, and to edit. A lot of people don't like VI, but it's what I use most often. Okay. Let's start it. So if we look where we're working, there is not a file called test.sh. We are going to open one. PI test.sh. So if there was a file called this and we VI'd that file, it would open it. But since it doesn't exist yet, doing VI to this file name is going to start the file and open it. It's, you see, new file right here. Now, using VI, you have to know some shortcuts. And the one most important shortcut is when you open a file with VI, you cannot type anything in that file until you turn insert on. Now, the easiest way to do that is to type the I key. Lowercase I will change it so we can insert into this file. You'll see the word insert down here, and you can type things now. We do not need this typed, so I'll delete that. let's go back over here. Yes, so press I on your keyboard to change into insert mode. I think you can also push the insert button on your keyboard. I don't know. So we have to turn insert on. And then you can type the following command. I do recommend you type it. I'm not going to take the time to do that. Let's hope this works. Okay, so I'm going to paste. Yes, okay. No, hide. Okay, so I have typed this into my VI'd test, my script. I have opened a script and I have typed some information into it. Yours is not going to look exactly like this because for some reason it's highlighting spaces. It's kind of nice because if there was anything after this backslash, you would want to deal with it. That's why I tell you only type. Do not copy and paste like I just did. I'm going to do something to make those disappear. You're not going to do this because you don't have to. I'm going to do something silly. Okay, so I made that highlight disappear. So you can see what it's doing now. So we're saying for this variable $1, it's going to be a file that we're going to import into our script. For this file, I want to grep everything. So dot is sort of like a wild card. I'm going to grep anytime there's a character in this file. We're going to pipe it to the next command. And we have this backslash because we want to arrange this line of code nicely so that each of these commands is on a different line. This backslash just tells the code continue to the next line. So we're going to send this to our sort. Then we're going to ask for the unique records. Then we're going to send it to another sort. Just like we did in that one long line. It's just this is broken up into different lines. Now, insert again. We could take these out. And I don't like doing that, having those. Okay, so now it's all on one line. Our grep command, our sort, our unique, and then our sort. And each one of the information is getting passed on to the next command. Up here, there's a little bit of script in blue. It's hard to see, but it just initiates that this is a script to be run in a bash environment. Every single script you run is going to start with that. Okay, so since we've typed, we've been in insert, we've typed our commands. To save this file, we need to hit escape and then colon, you'll see it happening down here, colon WQ to W means save, Q means quit. So we've gotten out of the insert mode. We've done colon, we've done W and Q, and now we can enter. And there is a test.sh script. You can cat it. Okay. Test.sh has our command. Now, what are we going to do with it? Okay. So this $1, it's going to be a variable argument that we give to our script. We can look, I already looked at where this script is living. We can look at permissions of this script. Okay, test.sh. And so these are the permissions of the script. It tells who can read it, who can write it, and who can execute it, which means run the script. Let's see. And this explains, it's all in sections of 3 characters. And the 3 characters mean read, write, and execute. The first set of 3 is for the owner. The second set of 3 is for people in your same group. And the third set of 3 is for people outside of your group, outside of your project. Now, what we're going to do is we're going to change the permissions for this file. We're going to use the chmod command, which is change mode, to have different permissions. Let's copy and paste that. Okay, so we've changed the mode to have UG plus X. So let's look at how that changed. What changed? We added execution for users and people in your own project. So the X means, is this file executable? Can you run it? Then the U is for yourself, and the G is for members of your same project. Yes. Okay. So we have changed the permissions so that we can run the script. It's the important part. So now, next we're going to actually run the script, and we're going to give it the input of our chromosome 22 file. So we're going to do /, which is the code used to tell Linux to run the script, /test.sh. We could run it like that, and it would be confused because there's no input. I don't know what to do. So don't do this. I'm going to do Control-C to kill that. We're going to do /test.sh, and we're going to provide it with an input. Because if you remember that $1 means that it's looking for an input. Chromosome 22.fa. So it's going to read in our chromosome 22 FASTA file, and it's going to run the script, the line of code that's in this test.sh. Hopefully. Let's go back. What are we supposed to read about it? So it's going to take several minutes to finish, and it's going to print to the screen this information. So what is it doing? The script is taking every character in your FASTA file and splitting it into individual lines. It's kind of silly, but we're splitting the entire file into one character on each line. And then it's going to sort them so that the occurrences of any given character are together in your file. And it's going to collapse them into the unique characters and count them. And then it's going to sort them. Here's it. Yeah, it's going to sort them negative. It's going to reverse numerically sort them. The R means reverse. The N means numerically. Yeah, so that's what it's going to do. Let's see if it finished. Yeah. Okay, so the most frequent character in our chromosome 22 file is a capital N. And then there are A, G, C's, and T's in here, which makes sense. There is an R and an H, and there are 2 2's. I'll leave it up to you to realize why are there R's and H's and 2's in this file. Think about it. Okay. So that is how we can run from the command line a script that we've written. Now that we've done that, I will tell you, you should not do that. A supercomputer is set up so that when you log on, you're on the master node, is what it's called. And if you run computationally heavy scripts on just the login node, you're going to slow down everyone else who's trying to use OSC right at that moment. And OSC will get upset with you. They'll probably send you an email. So don't do that. If anything takes longer than 10 minutes to run, it's going to quit anyways. So it is not a good practice to run things on the login nodes. What you should be doing, well, let's take a break here. Okay. We're going to stop right here.